Good morning, student. Today we will discuss about basic of motion, chapter 8, class 9. These are the building blocks of physics. On basis of motion, we will cover like motion, different type of motion, force, work, energy, etc. These all are the building blocks of basic of motion. This is the lecture overview, but we will cover the topics. What topic we will cover like a motion in a straight line, 1D or linear motion, basic of motion, reference point, distance and displacement, and numerical related to distance and displacement. In today's lecture, we will cover this all topics. One factor describing 1D motion. 1D motion, one dimensional, yeah, unidimensional, you can say straight line motion. Position denoted by x, time denoted by t, distance denoted by t, displacement denoted by small s, speed denoted by capital S. Displacement small s, speeds capital S, velocity v. Sometimes velocity is also mentioned by s, but you will understand. Acceleration a. Why we are denoting position x? Because it is a one-dimensional motion. You can say straight line motion. That's why we defining position as a x. Okay. Suppose I am standing here in the center of the board. If I am moving this side, I am moving to the left side of the board, then I am again coming in the center of the board, then I am moving to the right side of the board. See, I am moving in the one direction of this line. This is the straight line here, you can say 1D motion. 1D motion, we can move like that, we can move like that. Discuss about a reference point. See, what is reference point? Before explaining that, suppose I say you guys, tell me your house address. How you will explain? You will explain, sir, my house number is 126 in Kitchener, near to Gurdwara. Near to Gurdwara means you are mentioning some landmark. Gurdwara, near to petrol pump, or backside of Mandir. These all are landmark. Okay, these all are reference. In physics, if we will say these are reference, because you are saying from Gurdwara my house is 10 km, from Mandir my house is backside of Mandir. These are reference points. So to define the position of any object or body, see, we need reference point. Okay, without reference point, we cannot define the position of object and body. Okay, in the childhood, I think you studied about number line. In number line, suppose this is number line. If I say some person is standing here, so someone tell me how far that person is standing. So it's difficult to explain. You say, sir, from where? From where mean you are looking for some point, a reference point from where you can define the position of that person. Suppose if I mention that is origin. Okay, that is origin. So now you can say, sir, from this origin to this person position in 3 meter, whatever, yeah, 5 meter. It means with respect to this origin, you are defining the position of that person. Mean that origin is reference point. In Cartesian plane, you also studied about reference point. In Cartesian, we was defining that 0, 0, that is origin. With respect to this origin, we are saying this side is positive, this side is negative, like that. This origin is, I think this origin is reference points. This origin is a reference point. Now, suppose this is school building, this is Ram building. This is Ram house. This is Sham house. Hmm? 100 meter. 100 meter. So if we are considering school as a reference point, so Ram house distance will be 100 meter from school. Sham house distance will be 200 meter from school. Mean according to the reference point, distance of the Ram house and Sham house is varying. If we are considering Ram house as a reference point, then we will say Sham house from Ram house is 100 meter and school from Ram house is 100 meter. Mean if we are changing reference point, with the change of reference point, this position, you can say with the change of reference point, distance between objects also vary. I will explain one thing. See, if you will see, if train is moving, on the track, train is moving, and this is platform number 1. One guy is standing at platform number 1, and one person is standing platform number 2. Okay. According to platform number 1, the position of train will be different. According to platform number 2 person, position of train will be different. Meaning, if I am considering P1 reference point, then position of train will be different. If I am considering P2, position of train will be different. Mean if we are considering more number of reference point, then position of object will be vary. So to define the position object, we always consider one fixed reference point. We cannot consider multiple reference point. We have to consider one reference point to explain the position of object. So from there we can say that what is reference point? It is a fixed point. Fixed point means, you understand fixed point, if we will vary, then position of the object will be changed. So it should be fixed. It is a fixed point considered on line, surface, plane, mean at 1D, 2D area, 3D area, so that motion, you can say position of the object can be defined easily. Okay. Can be defined easily by locating the position of object. Okay. It is a fixed point. I explain it is a fixed point. Considered on line, surface, plane, 1D, 2D, 3D, so that motion, the position of object can be defined easily by locating the position of object. So now, on the basis of reference point, we will explain further things, the rest and motion. Now, I will explain about difference between rest and motion. See, now you will see this reference point plays major role to define an object is in a rest position or in motion. Rest means object is not moving, motion means object is moving. Suppose I am standing here. I am in rest position or in motion position. Some student will say, sir, you are in rest position. Some will say, sir, we don't know. See, this all depends upon the rest. See, if I am standing here, I am also standing on the earth. If earth is moving along with the earth, I am also moving. If someone will person say at the moon, see, I am moving. But see, you are sitting in front of me, so according to you, I am in a rest position. So you will be very surprised what the thing I am going to say. Nobody is in the rest position, nobody in motion position in all this universally. Universally, nobody can be in a rest position, nobody in motion universally. It depends upon the reference. According to the reference, object can be in rest position. According to the reference, object can be in the motion. Suppose this is bus. In bus, these two persons are sitting, and on the road one person is standing there. Okay. According to these two, according to this person is rest position. According to this person is rest position. Mean inside bus, two persons are sitting. They are in rest position with respect to each other. But if a person is standing outside on the road and watching that bus, according to that guy, the bus is moving. According to that person, both persons are moving. Mean according to that person, both persons are in motion position. See, now you can say with the variation of a reference, with the change of reference, position, rest and motion of the object can be changed. So, see, now you will say, sir, it's very difficult to define. Now, how can we define the rest and motion? So to define the rest and motion, we will consider time as a reference point. We know time is continuously moving. Okay? So according to time, we will define rest and motion. Mean any body or any object, if no change in position with respect to time, that means that body is in rest position. If change in position with respect to time, that means that body is in motion. Now understand, if no change in position with respect to time, if suppose if I am standing here at 5 o'clock, I am standing here. Again after 5.5 I am standing here. Yeah, after you can say after 6 o'clock I am standing here. That's means with respect to 1 hour I have not changed my position, so I am in rest position. Suppose if I am standing here at 5 o'clock and 5:10 I move there and 5:15 I move there. According to time I am changing my position, so I am in motion. Now displacement topic I will explain about scalar and physical quantity, scalar and vector. There are different type of quantity, physical quantities. Scalar quantity and vector quantity. Scalar quantity, to define scalar quantity we need only magnitude. Now you can say value. Value only or magnitude only. Mean to define any quantity, if we need only magnitude, we no need to any other thing, that is scalar quantity, like distance, speed, etc. These are a scalar quantity. Okay? Suppose if I am going to my any relative house, that is 300 kilometer. I am again coming back to my home, that is 600 kilometer. If you see the reading on your bike, that will be 600 kilometer. That is scalar quantity. Okay, if I am going to relative, I am coming to bike does not denote, yeah, bike does not count the direction of that. It count only the distance covered by me. That is 600. That is a scalar quantity. Now vector quantity. Vector quantity we will define magnitude plus direction. The vector quantity, to define vector quantity we need also direction. Example like force, velocity, displacement. Example, if I will say I am putting force on somebody, you will say, sir, how much, in which direction? Okay? So if I am saying I am came out from my house and started moving in one direction, your question will be, sir, in which direction? So when we need to define something, need some direction, that is called vector quantity. Okay, now parameter of motions. Now we will explain about parameter of motion. Distance, displacement. So distance, suppose these are 2 points, A and B. These are 2 points, A and B. How can I reach to B point? See, I can move like that. Okay? I can move like that. I can move like that. I can move like that. Okay? There are, I can move like that also. Okay? See, to reach AB, there are indefinite, yeah, you can say infinite number of ways to A to B. If I want to reach B, there are infinite number of ways to reach B. So if there are infinite number of ways to reach B, so that means there are infinite number of distance. Mean A to B I can reach in an infinite number of way of a distance. But displacement will be always 1. So displacement will be always 1. It will be in the shortest distance covered between both points. See, A to B, which is the shortest distance, that is a straight line. If I will draw straight line, that is the shortest distance covered between A and B. So now I can say distance. What is the distance? Actual length. Actual length covered by an object, that is distance. Shortest length that is the shortest length covered by an object. See, in this case, these are so different way of reach V, and this is the shortest length. The center straight line is the shortest, that is the displacement, and remaining are the distance. But think, distance and displacement can be equal. Suppose you are saying, sir, why A is moving in this wavy ways? See, A can also move in a straight line. A can move also in a straight line. That means distance and displacement can be equal. Distance and displacement can be equal. So I told there A can reach B2 in a different way, in infinite number of ways. So mean distance can be defined in infinite number of ways, but displacement will be always one. Only one infinite number. Infinite number of ways. And now I will say, see, I told you A can also move in the straight line. That means distance can be equal to displacement. Okay, now I see, suppose A is moving to B and coming back to same position. If A is going to B and coming back to A position, in this case, distance will be A plus B, AB plus BA, and displacement will be 0. Displacement will be 0. Mean you can say distance can never be 0, displacement can be 0. Okay. Now we will discuss about one numerical. From that numerical you will understand better what is the difference between distance and displacement. Okay, now we will discuss one numerical related to distance and displacement. See, numerical, a body moves in a circular path like that, A to B, B to C, C to D, then D to A. Then we will find distance and displacement. There we found need to find distance and displacement 4 ways. If a body move to A to B, then A to B, B to C, then third way A to B, B to C, C to D, fourth way A to B, B to C, C to D, then D to A. See, first two I will explain, but remaining two you have to do. That is your homework. First two I will explain. See, A to B. If body is moving A to B. Okay. So in A to B, how much distance covered by body? That is 1/4 curve of a circle. Okay. And shortest distance covered in A to B, if I will draw straight line, that is the shortest distance covered into the A to B. See, total parameter of a circle 2 pi r. Okay. Total parameter of circle is 2 pi r. See, if I will divide circle in 4 parts, 1, 2, 3, 4. What is this? This is the 1/4 part of the circle. Mean distance is, if I will say, distance is 2 pi r divided by 4. Okay. Now if we will calculate, pi is 22/7 and radius is 7 and divided by 4, 11 centimeter. because the unit was centimeter. So how much distance? Distance is 11 centimeter. Now we want to calculate displacement. How we will calculate displacement? I told displacement is the shortest path. If we will see, this is, what is this? This is 90 degree. This is like a Pythagoras theorem. If this is 7, this will be also 7. How we will calculate Pythagoras? Okay. 7 square plus 7 square. Okay. That means 49 plus 49. It is equal to 98. It is approximately 7 root 2. Okay. It means this is the displacement. Understand? AB is how much distance is covered? 11 centimeter. Displacement is 7 root 2. Now in stacking A to B, now person move to up to C. In this case, how much distance? Now how much area covered by that person? That is the half of the circle. 2 pi r divided by 2. If I will 2 pi 22 by 7, r is 7. So how much distance is 22 centimeter. Now this is the distance. Now displacement. Displacement, what I said, displacement is the shortest distance covered between object. So person started from A and reached up to C. So shortest distance between A to C, that is the straight line. If in circle, that straight line is diameter. Diameter is 2 into r. R is 7 centimeter. That means 14 centimeter. This can now see A to C, that is the straight line. This is the shortest distance covered between during this ABTC, that is displacement, and total distance ABC, that is half of the circle. Parameter of circle is 2 pi r. If we divide by 2, that is pi r, 22/7 is 7 by 22 centimeter. And this remaining third and fourth, so I will not do, you have to do in home. Okay, understand?